All right, class. So today's video is the Unit 1 review portion in preparation for the semester exam. So you know your semester exam will cover Units 1, 2, 3, 4, and 5. Today's video is going to cover a little bit of a review to get you ready to really do well on those questions that might be coming from Unit 1. So let's go ahead and get started. So let's talk about piecewise functions. So a piecewise function is when we have two or more functions. Okay, so like we see here in this first example, we've got three functions, right? The line 2x, when x is less than -2, and that's going to be this line right here in red. Okay, the next line that we have is -1 minus x, and that's going when x is between -2 and 4. That's this line here in green. And then the last line we have is when f of x is equal to -3 when x is greater than or equal to 4. So that's what's happening here. Okay, and we want to discuss domain and range and everything that goes with these types of functions. And so when we're reading it, remember when we're talking about domain, we're going from left to right. So how far from the left are we going, right? Or are we coming from? If we look at this red arrow here, well, we know this is going to go on forever into the left. So we're actually coming in from negative infinity. And we'll see that it stops here at -2. And you'll actually see that in the restrictions here. It stops at -2, and it's a solid point. And we know that also because it's less than or equal to -2. That's when we use the brackets, right? Well, we know it picks up at -2 here on the green line. And that's the parentheses because it's not inclusive. And it goes all the way on till 4. And it's also open, so it's not inclusive. And then it picks up here on the blue line at 4. It touches 4. We know that because it's greater than or equal to 4. And then how far to the right does it go? We see that arrowhead going forever. Well, look what happens. We're going from -infinity to -2, but it includes it. And then we go from -2 to 4. Nothing includes 0, but it starts at 4 again, which is inclusive to infinity. So this is actually going from -infinity to infinity. Or what you guys already know is all real numbers. As far as the range is concerned, well, the range is a little more interesting here. Our range is when we're looking how far down it goes, right? Because we're going from down to up. As far down as it goes, well, it's going to go down forever. You see the little red arrows pointing down, so we know that it's going to go from -infinity. And then as it goes up, it goes up, it goes up, and then we see here that it goes 1, 2, 3, 4, -4 right here. As far as our y value, it's how far up it's going. And then you'll see that the green line kind of goes up a little further, and it goes up as far as 1. But we wouldn't include, we would say it goes up to 1, but it never exactly touches it because it's an open circle. And so we'd go from -infinity to 1. And that's as high as the graph goes. Okay, so then here on the student practice part, I do want you guys doing this in your respective Pear Deck. Hint, hint, your domain is going to be very similar to mine, but your range is going to be different. So please be very careful with that. Okay, if you have any questions, send me a message. But let's go ahead and move on. So we're also going to discuss inverse relations. So we know the inverse relation is written as, well, anytime we talk about inverse, it's that value to the power of -1. Like if we had f of x, we would say the inverse of that would be f to the -1 of x. And to find this relation, this is when we have to switch our x and y values. Okay, we have to switch the x and y values, and that's what we're always doing, right? So we also discussed one-to-one relations, and when something was one-to-one, it passes the vertical and horizontal line tests, and that's given graphs, right? If we're not given graphs, we need to make sure that both the function, actually it shouldn't be function, that's incorrect. We would say the relation and its inverse are both functions. Okay, well, let's look at an example here. So we have this relation of -1, 1, -2, 2, 4, 3, -1, and 4, -2. Let's go ahead and label these real quick. xy, 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 and xy. And if we're addressing the inverse of this, well, we know that we're switching our x and y. So 1, -2 becomes -2, 1. 2, 4 becomes 4, 2. 3, -1 becomes -1, 3. And 4, -2 becomes -2, 4. So everything switches. Now, is R a function? So we're looking at this first relation, and we want to make sure that it's a function or not, or identify that it's a function or not. We already know, we've discussed this, and we've drilled it to death, that our x values cannot repeat. So when I'm looking at my x values of 1, 2, 3, and 4, well, none of those values repeated. So yes, this is a function. Now, is the inverse of R a function? Well, we're going to look at those x values at -2, 4, -1, -2. Well, you see these -2's here, those repeat. So the inverse is not a function. So because the inverse is not a function, then R itself is not one-to-one, because we would need both of these to be yes. So this is a no. So now I would like for you to do this next part here on your own in your respective Pear Deck. If you have any questions, please send me a message. But let's go ahead and move on. So when we're verifying inverses, we know that two functions, like let's say we're given two functions, f and g, we will know that they're a function if and only if we were to take one, in this case we'll take g of x, and we compose him into f of x. In other words, we put him inside the other one, and it equals x. But we also want to be sure that when we do the opposite, when we take f of x and we put him inside, or we compose him inside g of x, we should also get x. So if we look at this problem here, we're given f of x. To get the inverse, well, we know we're going to write this as y equals 6x minus 15. But if I want the inverse, I need to switch my x and y. Look at x equals 6y minus 15. And then we need to solve for y. So I'm going to add 15 to both sides. I'm going to get x plus 15 equals 6y. And then to isolate y, we need to divide both sides by 6. So for the sake of time, I'm going to come up here and just rewrite this, that we get y equals x plus 15 over 6. And really it should be f inverse of x equals x plus 15 over 6. So if these two are inverses of each other, if I take this guy and I plug him in for x, I should get just x. Well, let's find out. Let's do f. We composite this in here. And this could also be our g of x in this case. We'll say 6 times x plus 15 over 6 minus 15. Well, when we distribute the 6, we know that everything on the numerator is going to be multiplied by 6, but then divided by 6. So what happens is these two values would simplify out. So we would have f of f inverse of x equals x plus 15 minus 15. We can then combine these two like terms. Well, 15 minus 15 is 0, and we get that the composition of the function and its inverse equals x. So these are inverses of each other, and this is a proof. So if you're able to compose any two equations like that, and you're given x at the result, then they are composites of each other. In your Pear Deck, you will see this question here, and I want you guys to do the same thing. Make sure that you address how we know if a function and another function are inverses of each other. I want you to solve for the inverse of this function of 8x minus 12. Once you have that inverse, plug one inside the other. It doesn't matter which way you do it, as long as you get x at the end, you did it correct. Okay, please message me if you have any questions, but I will be checking on you during class. Let's go ahead and move on. So in this one, we have a system of inequalities, and they want us to identify the shaded region. Okay, so this is one of those questions where you could easily do this in Desmos, but let's do this by hand. You can use Desmos on your own, but I want to make sure that you can see me do this by hand as well. So I'm going to graph this first equation. I know my y-intercept is at -1. So I'm going to put a point here at -1. And then my slope is -2/3. So I'm going to go down 2, 1, 2, and then over 3, 1, 2, 3. So here is my line. And I'm going to use a solid line because I see that it is less than or equal to. So I have my solid line here. Okay. And I need to shade below because it's less than. So I'm going to shade below. I don't want to make it too dark. So I'm going to have extra shading in just a bit. My next equation, and I'll do that here in blue, my y-intercept will be at -8. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. And then to graph my slope, I go up 1 over 2. And I'm going to use a solid line because it's greater than or equal to. And I need to shade everything above. So I know it would be everything like this. I know it's getting a little messy, but you can already see where we have two double shaded regions. And then my last line is x is greater than 4. So I'm going to go over to 4, and I'm going to go 1, 2, 3, 4. And because it's just x is greater than, we know that's going to be a horizontal line, and it's going to be dashed. And it's dashed because it's not equal to. But we need to shade everything to the right of that because we're talking about everything that's greater than. So we only have one area that is shaded by all three regions, and that is this triangle right here. And I'm really going to darken that in. So this is a good skill to be able to see or to have, is to be able to find those extra shaded regions. So your point will need to be somewhere in here. Okay? Well, you're going to take that skill and you're going to use it here in the next problem. Let's take a look at that right now. So you have two equations, and you're going to be looking for a point that's in that double shaded region. So you can use Desmos on this. I'd rather you try it by hand, and you're going to see which one of these 4 points is in that double shaded region. Okay, let me know if you need any help. Send me a message, but I'll check on you guys during class as well. Let's go ahead and move on. And so we have this last problem here to perform the indicated operation. So what you'll see here is the question is asking us to find when we take the function of g times h when x is -2. Oh, okay. So we're multiplying the two equations. Well, what we can do here is we can take that g of t and equal it to 4t minus 5. And we can do this at the same time of h of t, and equal that to t minus 3 squared. What happens here, okay, is we're going to substitute in negative 2. We're going to have g of negative 2 equals to 4 negative 2 minus 5. And we're going to put in negative 2 in this equation as well. So negative 2 minus 3 squared. Okay, when we start working this out, we'll see g of negative 2 is equal to negative 8 minus 5. And we get that g of negative 2 is equal to negative 13. Okay, now this is not our answer, so just pause there. Our next part here is we have h of negative 2 equals, well, we're going to end up doing negative 2 minus 3 is negative 5 squared, which ends up being 25. Well, then what we need to do is the operation here where we do g times h. In other words, we're doing negative 13 times 25. Okay, so you're not expected to know how to do this like in your head to how to do negative 13 times 25, but you definitely want to have that practice of pulling up the calculator in Desmos. And you end up getting that the answer to this is negative 325. Okay, so we solve both parts and we do the operation it's asking us to do, g times h, which is what we did there. Okay, so on this question here, I want you to do the same thing. You're going to plug in 5 for those x values, and whatever you get for g, whatever you get for h, you're going to multiply them together. That's it for this video today, guys. Hopefully it helps. Please ask me any questions that you may have, and best of luck. Thank you, guys.